Hello and welcome back to For a Green Future. Could you please share with us your name and who you're with?
Yeah, Mark Jacobson at Stanford University.
Yeah, well, thanks for coming back on the show, Mark.
Yeah.
I've been following your social media posts all summer, and you're there in Stanford in California, and it's been kind of a record-breaking year there in terms of alternative energy, hasn't it?
Yes, well, on the main grid, which supplies about 82% of California's electricity, clean renewable energy, which is really wind, solar, geothermal, and hydroelectric power on California's grid, has supplied over 100% of demand on so far 217 days this year, for, on the order of 3 or 4 to 4 hours a day on average over all days of the year, and has displaced about 37% of gas over the last 2 years. So gas use is down 37%. And really what's grown is solar, utility scale solar, and also behind the meter solar, rooftop solar, which has reduced demand. So rooftop solars help reduce demand. Utility solars increase supply. Batteries are then taking excess utility solar and shifting that solar electricity to nighttime, displacing the gas. So huge growth of solar, huge growth of batteries, and growth of both utility solar and behind the meter solar.
Hmm. And essentially, it's breaking records practically every day, right?
Well, yes. I mean, last year and the whole year, there were about 135 days of the year where the wind, water, solar supply exceeded demand for part of the day. We still have about a month and a half left of this year, and we've already had 217 days this year. But also the average so far, about 55% of all demand over all hours of the year has been met with wind, water, solar this year. That's almost 4% higher than last year. Last year was around 51% at this time. So if we actually extrapolate that out forward, if we continue growing at that pace, California will be 100% renewable 24 hours a day, 365 days a year by around 2037, 2038. So within 12 to 13 years, which is really good news. And but we need to address not only electricity, which this is we're talking about, but also transportation, buildings, and industry. Those sectors need to be electrified, and then we'll need more electricity for those sectors really to be 100% renewable across all energy sectors.
Mhm. Now, part of the good news, part of the things that you talked about is the fact that once we do that, once we electrify everything, we actually need less energy overall.
Yes, electrification of transportation, for example, reduces energy use a lot. Like an individual car that runs on gasoline versus an individual car that runs on battery electricity. Battery electricity car uses one-fourth the energy as a gasoline car. So even though we'll need more electricity to run a battery electric car, we need less overall energy when you combine electricity plus the energy in gasoline, for example, less overall energy to run transportation by electrifying transportation. Same thing with heating buildings. When we use electric heat pumps, an electric heat pump uses 75% less energy than a gas heater. So even though we'll use more electricity with electric heat pumps, we use less overall energy. So we will need more electricity overall when we electrify all energy sectors, but we're going to need a lot less overall energy. And we can then provide the electricity from clean renewable sources, so eliminate the greenhouse gases associated with energy. We can eliminate the air pollutants associated with energy, and we can provide more energy security with clean renewable energy versus fossil fuels.
So it wasn't that long ago that utility officials, so-called experts in the field of electricity and energy, were saying that numbers like the ones we're seeing were actually impossible. Um, that grids couldn't handle more than 50% from renewable energy sources. Um, you've always maintained otherwise. In fact, you maintain we can get to 100%. wind, water, and solar, and in fact that we have to. Does it, do you feel vindicated by the actual numbers that are coming in California and other grids around the world?
Yeah, in fact, it was about 2009, 2010 that people were saying we can't get more than 20% renewables on the grid. And that's just a made up number. That number subsequently was increased to like 50%, then 80%, then 90%, then 95%. There's no limit to how much renewables we can have on the grid to have stable grids. And there are 12 countries in the world that are 100% renewables on their grid. And, they're dominated by hydro, but there are now many grids that are dominated by wind that are over 100% renewable. South Dakota for the last year, at least from mid 2024 to mid 2025, was 120% wind, water, solar as a percent of its demand. So
Hmm.
it produced 88% of its demand from wind, another about 30%, close to 30% from hydropower, and another 2% from solar. And so it had more electricity, it produced more electricity than it needed. In addition to the wind, water, solar, there's another 17% from fossil fuels. So it produced more than it needed and exported the difference. The point is that it produced over 100% of its demand from just wind, water, solar. In fact, there are 11 states that in the last year produced between 50 and 120% of their demand from wind, water, or solar, and seven of those states are dominated by wind. So we're just seeing more and more that this whole myth that you can't run a grid on clean renewable energy because of its intermittency is just nonsense. I mean, we have batteries as backup. Hydro is the biggest type of backup in the world. Pumped hydroelectric is the second biggest, and batteries are now growing and displacing gas all over the place. In California, we see this, that there's so much batteries on the grid. The battery peak capacity is about 45% of the average power demand on California's main grid. And these batteries are 4-hour batteries. So in other words, these batteries on California's grid can supply 45% of the average power demand for 4 hours.
Hmm.
And that's almost all those batteries were just installed in the last 2 years. So you can see that we can double, triple in the next 4 or 6 years. We can, triple the number of batteries we have on the grid, and we'll meet not only the average power demand with batteries, but the peak power demand with batteries, if necessary. I mean, we can also add more solar. We can add enhanced geothermal. We could add offshore wind. We can do a lot of things to get to 100% renewables 24 hours a day, 7 days a week, not only in California, but everywhere worldwide.
Hmm. And this is all happening in California, despite the fact that you folks are building your share of data centers out there, right? The
Yeah, California has the third most data centers in the US. And it not only has that, it has by far the most electric cars, and it has a huge number of electric heat pumps. So despite all this growth of data centers, electric cars, electric heat pumps, actually the demand on the main grid this year is down 2% versus last year, largely because of the growth of behind the meter rooftop PV. When people put solar on their homes, for example, they use that electricity first, so they need less grid electricity. So even though there's an increase of demand for grid electricity due to cars, heat pumps, and data centers, that a lot of that's being offset by rooftop solar. So that's really the first line of defense against these big data centers is build more rooftop solar, put solar on everybody's roof. I mean, you can fly over, who has the most data centers? Virginia by far, then Texas and California are almost tied for second and third. And, Virginia, they're talking about, well, what are we going to do with all these demand for new data centers? Well, it's obvious. Put solar on your roof, on the rooftops of all your homes and businesses. And even ask people who want to build data centers, have them, if they can't build a new solar plant to supply their solar, have them purchase people's rooftop solar and battery systems to offset the data center use, because that will do the job as well. And it'll be actually more effective because that's an effective way because people individually can then, especially if they have batteries, uh, can smartly reduce grid electricity demand when it's that you have peaks in demand, like in the late afternoon or evening in a lot of places. Anyway, so
Could
there are solutions to all the problems we face if we actually think smart and stop thinking about gimmicks. Gimmicks include adding carbon capture to fossil fuel plants, taking carbon out of the air. That's a gimmick. That just increases carbon dioxide because it takes energy, and that energy is usually renewable, and using renewable energy to take carbon out of the air prevents that renewable energy from displacing a coal plant, which would eliminate more carbon and more air pollution. And so effectively, carbon capture is always increasing CO2 because it's an opportunity cost. Biofuels is a ridiculous opportunity cost. 1.24% of all US land is needed just to grow corn for ethanol for only 4% of US transportation energy. And it doesn't reduce any carbon because all the energy it requires to produce the ethanol and transport it. And it's just a waste. It produces air pollution just like gasoline. So no benefit whatsoever. Nuclear, you can't even build it in less than 17 years in the US. Doesn't matter if it's small modular reactors or even worse because they don't exist. They're vaporware, non-existent technology that people just pretend as if they're existing and they're being built. They're not. They're not even approved for anything.
mm,
And they're not being built and they're not licensed. They're not commercial. And they'll take, even if they were, they would just take just as long as large reactors and they'd be even more expensive because we went down to small reactors where people started talking about small reactors, not remembering that the reason we went to large reactors is because of economies of scale. So there's, useless solutions that are being pushed, and because we're wasting time in the US with these useless solutions, we're not transitioning as fast as we should be, as fast as many other countries are,
mm.
such as China. China's transitioning way faster than the US because they're focusing on clean renewable energy and electrification, not on gimmicks and nonsense.
Right. I guess China actually their CO2 production has finally plateaued there after going up for many decades uh, because of the solar. So the argument that's being made by the Secretary of Energy, by the president, that we need to build, I think they said 10 new large nuclear plants because of the demand by data centers. That the facts on the ground, what's actually happening, says that that's not true, basically, right? Sort of disproves that.
Well, I mean, they could say we need 10 new data centers, but they're not going to build them because, again, you can't go from planning to operation of a new nuclear plant in the US in less than 17 years. So they can talk all they want, squawk all they want. It's not going to happen. And it would cost, if they did, it would cost like the last two reactors that were built, they cost 34 to 35 billion dollars or almost $16 a watt compared to new solar is less than $1 a watt.
Yeah, you're
And
talking about the Vogtle plants in Georgia.
yeah, in Georgia. And so they want to take something that, and it only takes like half a year to put up rooftop solar, but a year to 3 years these days for utility solar versus 17 to 23 years for a new nuclear plant. So you're going to end up waiting like 14, 15 years more for something that costs, in terms of capital costs on the order of 16 times more. It's just silly and nonsensical, and it won't help anything because it won't be built. And so it's just a distraction from actual real solutions.
So we're finally on the path, basically. We're heading in the right direction, even though we're doing it too slowly at this point. But you kind of laid this path out, didn't you, in several books? Could you just remind our listeners the titles of your books?
Well, I have a new book coming out in January called Still No Miracles Needed, which
Ah,
is a follow-up from a previous book called No Miracles Needed, which is really how we can solve our climate, air pollution, and energy security problems with existing technology without the need for miracle technologies. Anyway, it's an update and it describes in detail what is needed for a transition. And but in the past, we've developed energy plans for countries and states starting in 2009. Um, and the more over time, these plans have become more detailed, but also the costs have come down. The technology costs have come down quite a bit. There are more technologies available. For example, we now have enhanced geothermal, which allows baseload. If you're a fan of baseload, you love enhanced geothermal because it allows baseload electricity, just like nuclear, but you can build it way faster than nuclear. Within take 3 years instead of 17 years from planning to operation for enhanced geothermal, and it'll cost a lot less, and it's a lot safer. It doesn't have weapons proliferation risk. It doesn't have underground uranium mining lung cancer risk. It doesn't have meltdown risk. You don't have to store waste for 200,000 years. So enhanced geothermal is a good technology that you can put pretty much anywhere. And this is another solution for data centers if people are interested. There's also fire brick storage for high temperature industrial heat. Um, Before you needed furnaces on demand for high temperature industrial process, but now you can store heat up to 2000 degrees Celsius in fire bricks using resistance heating elements in the bricks. So whenever you have extra wind or solar, that can be used to generate heat in these bricks, and you store that heat for hours to days to weeks. And when you need heat, high temperature heat, you run air through the channels in the bricks. That air is then sent to heat a metal, and then it can use that waste heat from that can be used for even another process afterwards. So you can replace 90% of industrial furnaces with these fire bricks, and they're much lower cost. They're much lower cost than even batteries because they're made of dirt, basically. And so this is another technology that is very hopeful. Anyway, so we've had new technologies, lower costs, and actual examples of high penetration renewable grids that are breaking records every day.
All right. Well, we'll look forward to that book,
Well, it's Cambridge University Press.
Cambridge Press.
It's
Okay.
available most anywhere.